Number of defective items in a batch of 5 manufactured on a production line. That's a group of some kind. Probability item is defective is 0.12. We're looking for the expected value, right? So expected value, what? That means mean of a probability distribution, but what kind of distribution are we looking at here? All right, do we have, and I mentioned this in class a bunch of times, but it's very relevant here. I tend to look at the binomial distribution first, just because that has a very finite set of conditions, very easy to recognize. All right, fixed number of trials. Fixed probability. Independent events. And 2 outcomes. All right, 5 manufactured items. That's the fixed number of trials. Probability an item is defective, 0.12. I mean, I have no reason to think that that's not true for any item selected at random, which would lead to independent events. And 2 outcomes, well, defective or not defective. So that should be pretty straightforward, at least at first glance. Right? So the expected value would be mu equals NP, which would be 5 times 0.12. All right, so 0.12 times 5, that's what, 0.6? Let's take a look. Yep. Sigma is the square root of NPQ. It's really NP times 1 minus P, but a lot of folks will write NPQ, where Q is the, or known to be representative of 1 minus P, you know, just to make it a little simpler. Either way, it's more intuitive than anything else because you know it's the probability of failure where N is the P is the probability of success. All right, so we're looking at 5 times 0.12 times 0.88. All right, so I just got to do a little computation here. The other one I could at least attempt in my head. This one, I can attempt it all right. It's just not going to be instantaneous. All right, so about 0.727. All right, they're asking for the usual interval, so I'll have to chuck that down here. The usual interval corresponding to the random variable x. Usual means mu plus or minus 2 sigma. All right, so I want to hang on to this value, so I'm going to call that A. So store it as alpha math, so store it as A. All right, the 0.6 was easy enough, but so I could just type that, but I don't want to type that whole decimal, so, or even a rounded version of it. This is, in my mind, simpler, but my mind's an interesting place, so you never know. You can go either way with that. All right, so mu minus 2 sigma, mu plus 2 sigma. The usual interval would be negative 0.853. If we're rounding the 3 significant to 2.0533. Same deal, 3 significant. All right, so I have that part. D, the probability that no more than 2 items are defective. It says use normal approximation with continuity correction for this problem. Same deal for the next one, between 2 and 4 items. All right, so they're flat out telling us that we have to use that technique, even though it's binomial distribution, and we could use binomial techniques. The directions are telling us specifically to use the fact that the mean is this and the standard deviation is that to come up with z-scores and label up a diagram and all that good stuff. All right, so probability that no more than 2 items, so this is a capital X, no more than 2 would be less than or equal to 2. All right, although my capital X's don't look much different than my lowercase x's, you get the idea. All right, so I need a little diagram here. I always screw it up on the right-hand side. Okay, not too bad. Let me keep one of those over here for safekeeping. Use it later. All right, so the mean again is 0.6. I need to go out 3 in each direction. This will be fun. All right, so 0.6 minus A. All right, so that's 0.127, but negative. We already have minus 2A, so negative 0.853. And so we just grab a negative, replace the 2 with the 3. Negative 1.5, well, it would be negative 1.58. 0. And then we're going the other way. So all this stuff again, just with a plus sign. 1.327. .0533 from the previous problem, and from this calculation, 2.780. So less than or equal to 2 is going to be somewhere in this neighborhood. Continuity. I want to make sure I have enough area to include that too. So the continuity correction would make this really, x is, again, less than or equal, it doesn't make a difference because the end line doesn't have any width, it's infinitesimal. Less than or equal to 2.5, we always give ourselves half a unit of wiggle room on the high side if it's a less than or equal, half a unit of wiggle room on the low side if it's greater than or equal, and then we just finagle it if it's in between values, depending, right? Inclusive, exclusive, and so on. So the z-score is going to be 2.5 minus 0.6 over 0.727. All right, so crunch some numbers, bring up my calculator. Bring up my fraction tool, 2.5 minus 0.6. I shouldn't have hit enter. Go to, if you get a syntax error, it brings you to the scene of the crime, 0.727. So we're looking at 2.613. All right, that looks pretty consistent with the diagram. Although, oh, now that I'm looking at it, I realize that I made the diagram consistent with 2 rather than 2.5. 2.5 should be over here somewhere. All right. So we're looking at the probability that z is less than or equal to 2.613. So second vars normal CDF. On the high side, it should be about 2.613. So about 0.996. And that looks pretty consistent with the diagram. All right, so that's part D. Now part E is saying between 2 and 4 defective items. All right, so it just kind of begs the question of between 2 inclusive or between 2 and 4 inclusive or exclusive. Well, they didn't really say. So we just have to determine the response to that based off of the context of the situation. All right? Pick a number between 1 and 10. So if a person says 1, Are they following the rules? If they say 10, are they following the rules? That depends. It depends on the interpretation. I've seen it go both ways. All right? So as long as you're clear with how you're interpreting it and justify your interpretation, then you're in good shape. But there's a reason why we say things like inclusive, exclusive, just to stipulate. If those words are not included, then the context drives the situation, but also there could be instances like this where it's sort of in the eye of the beholder. So you look at it and say, well, this is how I'm interpreting it. I'm going to go through the process. As long as I'm explaining my rationale, I'm not going to lose any credit. All right? So in this case, I'm going to assume that 2 and 4 are valid numbers, all right? Because, and that this comes to the context, but also you can go back to that, pick a number between 1 and 10. I play by the rules where if you say 1, that's fine. If you say 10, that's fine, right? But in this case, you think about what it would mean if you did not include the 2 and the 4. You're talking about a number of defective items out of 5 that are manufactured. If I say pick a number between 2 and 4, but you can't include the 2, you can't include the 4, isn't that really the same as saying find the probability of 3 defective items? You know, it's a different question, right? Or at least it feels like a different question, right? So I'm going to say that this is the probability that we are between 2 and 4 inclusive. All right. Now with continuity correction, that would mean that we're looking at 1.5 to 4.5, all right, to give us that extra wiggle room corresponding with the normal curve, all right, the area under the normal curve. So probability going from 1.5, capital X, to 4.5. In terms of the diagram, well, the mean hasn't changed, the standard deviation hasn't changed, so the diagram shouldn't change, so that's good news. So I'll take this, copy, paste, and then start the journey of getting rid of all the red in here, or at least most of it. Oh, well, good thing I have a backup. That little tail there. Anyway, so I need to go from 1.5, which is right about here, to 4.5, which is off the graph here. So it's all this stuff here. All right, so it's definitely going to be less than 0.5 as a final answer. I just don't know how much less. All right, so that's where the computations come into play. All right, so I need a z-score for the 1.5. So 1.5 minus 0.6 all over 0.727. And then the same thing for a 4.5. All right, so crunching some numbers. There we are. TI doesn't have copy paste. This is the closest we get to it, but it's still pretty effective if you do it the right way. So about 1.238, and then put the 4 there, looks good, 5.365. All right, so what I'm going to do, just belatedly I thought of this, I'm going to store this one as A, and I'm going to store this one as B. Right next to the A is the B. All right. So when I do my normal CDF it should be a little bit more efficient. All right, so I'm looking for the probability that Z is between 1.238 and 5.365. So that would be second vars, option 2, going from A to B. .108 roughly. All right, and there it is.